geometry next year, some of the things you really need to be able to do to start out the year. You will start with a very mini algebra review the first week or so of geometry as well. That I cannot stress how important it will be that you can solve an equation. Equations with variables on both sides, equations with fractions, equations that have special solutions, all those things. So to solve linear equations, we need to make that bigger. That is too big. The first thing we're going to do is undo operations. Well, we're going to undo operations using inverse operations until the variable is isolated. So that is the overarching goal. So this is the end result, right? But before we can start undoing operations, there are some things we need to do first when necessary. Not always. Equations are different. If necessary, so if we have something that's outside of the set of parentheses that needs to be distributed, we're going to distribute that. Then we're going to add or subtract all the terms that are like terms, same variables with same exponent. The next thing we're going to do, if there are variables on both sides, so if necessary, we get the variables on the same side by adding the opposite of the smallest variable term to both sides. If there are 3x on one side and a 2x on the other side, we are going to add a negative 2x to both sides. That is a strategy for success. You could technically add the opposite of either one to both sides, but we are always trying to not have a negative coefficient because that's, well, a lot of kids make mistakes and there's a negative coefficient. So, if we add the opposite of the smallest variable term, once again, 3x on one side, 2x on another side, we would add negative 2x to both sides. That would get our variables on the same side. If the variables disappear, so sometimes when you have variables on both sides, all of a sudden you have no variables, right? So we learned that if the variables disappear and it's a true statement, it's a special solution. If it's a false statement, it's another special solution. So if the variables disappear and the statement is true, the solution is all real numbers. That means no matter what number you plug into that equation, it will make that equation a true statement. Or sometimes they say it will satisfy that equation. So remember, the answer in that case is not true. The answer in that case is not 5 equals 5 or 10 equals 10 or whatever. The answer is all real numbers because it does not matter what number you plug in for the variable. It will make that a true statement. And if that statement is false, in other words, if you wind up with something like 3 equals 7, your variable disappears, and you have something that looks like 3 equals 7. Well, that is not true. 3 does not equal 7. That would make that a false statement. So then the solution would be no solution. And you can also use the empty set symbol. A lot of kids like to use that. That means there's no solution. Not a 0. A 0 is a number, so 0 can be a solution to an equation. All right, so this is a very basic two-step equation. Does not require the if necessary here. This is a straight up undo the operations that are happening to the variable. We're going to start with that example. 5 times x plus 2 equals negative 4. If you want to know what's happening to that variable, read that not as 5x. Remember to make sure you read all of the operations. 5x means 5 times x plus 2 equals negative 4. So what do we do to solve this equation? What's the first thing we're going to do to solve this equation? So what are the operations we're undoing? Adding, subtracting, multiplying, or dividing? We are going to undo adding. Is there any other things we're going to undo? We're going to undo the adding by subtracting. So, yeah. Is there another operation we need to undo? We need to divide. We need to undo the multiplication, right? So we have addition and multiplication. So to undo the addition, we subtract. To undo the multiplication, we divide. Yes, we divide. And we, in this case, we're going to undo that adding first. So we're going to subtract 2. Another way to think that is adding negative 2 to both sides. They are the same thing, remember. 2 minus 2 is 0. Negative 4 minus 2. Remember to use your calculator. That's negative 6. You're going to negative minus a number that's going to stay a negative. It's going to be a negative farther to the left. So what we have left here is 5 times x, right? So Caleb already says undo multiplying, we're going to divide. So we're not dividing. You'd be surprised how many kids want to divide by negative 6 here. Negative 6 is always already away from this variable. We do not want to divide by negative 6. The 5 is with the x. We've got to divide by the 5. So x equals negative 6/5. It doesn't have to be a nice, neat integer. That is a perfectly acceptable answer. We should know how to turn that into a mixed number because we learned how to do it on our calculator now, but that's a perfectly acceptable form to leave your answer in. Just make sure that fraction is simplified if you leave it as an improper fraction. So we would not leave that as negative 12 over 10, right? It would have to be simplified. Any questions? Okay. We don't have a lot of these, just plain old simple equations in your homework. Most of them are going to be if necessary. So we've got a couple more things to talk about, and then we're going to do some problems together. So solving equations with fractions. Often you will want to eliminate the fractions before beginning to isolate the variable. So technically you don't have to get rid of fractions, but I am a long-time math teacher and I do not want to add and subtract fractions if I don't have to. I do not want to have to convert them to the same denominator because that's what you do when you're adding and subtracting fractions, right? So there is a way to get rid of the fraction. That doesn't mean you'll never have a fraction answer, though. You very likely may have a fraction answer if there's a fraction in your equation to start with. It just means we're not going to have to add and subtract fractions. We're going to wind up just multiplying our fraction away and then dividing at the end or multiplying at the end, and we may or may not have a fraction solution. Sydney, are you ready? To do that, we will multiply each term in the equation by the least common multiple of the denominator. Technically, any common multiple will work. We like to do the least common, that's the smallest multiple they have in common, because we get to work with smaller numbers, but it is not necessary for it to be the least common multiple. Remember, a multiple, basically if you're counting by numbers, those are the multiples. The multiples of 3 are, always start with 3. 3, 6, 9, 12, 15, 18, 21, goes on forever and ever, right? Multiple of 6 is going to start with the number 6. 6 is the smallest multiple of 6. 6, 12, 18, 24, 30, 36, 42, 48. Goes on forever and ever. I'm getting this off, give me one sec. So, after we do that, these are the steps to follow to isolate the variable. So, if all these if necessary things, but once we get through there, we follow the steps: undoing addition by subtraction, undoing subtraction by addition, undoing multiplying by dividing, undoing dividing by multiplying. That's what we're talking about when we talk about inverse operations. So actually that is really all the notes we are going to take. I'm going to let you scan and submit these notes, and then we're going to start working on some problems together. I will go back, yes. You're welcome.
Something for you to sign.
For what?
For the meeting. You weren't there.
Oh wait, today. I don't know what name it's supposed to put.
I think she put it.
I just put it. Let's see.
Alright, please.
You too. Okay, so let me put a due date and something to submit it, a file upload, and we will get started on doing some examples. So you can get your phones out real quick so we can scan and submit. If you don't have a phone and you want to use mine, you can do that. Alright, you should see it now. You only have to do 12 problems. I'm not probably going to work any of your problems with you. I'm going to work odd problems because you're only doing even problems, remember? Starts with 2. Multiples of 2. 2, 4, 6, 8, 10, 12. You're counting by 2 all the way up to 24, so you have 12 problems. You guys all caught up? Can I get off of here? Are you still working on this, the notes? Okay. Okay. All right, so this is the worksheet that you have. We're going to work some, you only have to do the even ones, but here's the deal. You have to do all the odd ones that I do with you now. So if we may finish all the odd ones before the class period is up, and that means your worksheet should come back incomplete. Is everybody clear on that? So I will exclude the odd problems that we don't work together. You have to do all the even problems plus the odd ones that we do together today. Does that make sense to everyone? Okay. So, we are going to go ahead and get started. We'll give Aiden another second or two to get his stuff submitted. Initially, we were going to have 2 days on each of these sections, but even before the days out, we were running out of days. Some years, our EOC is earlier in May, and then we have more days after the EOC, so this year though, we only had 5 school days left after the EOC, so we have to get busy to squeeze in our last unit, which means we'll just spend 1 day on 3 sections, we'll review on Monday, test on Tuesday. Alright, solve, so all work, and box or circle your answer. So we're going to start with number 1. We have a variable on the left side and a variable on the right side. So this one looks like a pretty easy one with variables on both sides, but this one is a little bit tricky because kids get confused here. So we're looking at variable terms. So one of our things is, if necessary, get variables on the same side before we start undoing operations, right? So what are my variable terms that you see? What are my variable terms?
Plus.
No? What is a variable term? That would be a term with a variable. So can you give me one of the 10 times x, right? That's one, 10x. What's the other variable term on the other side?
X.
Just x, right? So we said in our notes, because we have variables on both sides, we're going to add the opposite of the smallest one. Well, if that's a 1 and that's a 10, then we're going to add negative 1x here, right? Negative 1x here. And now we're going to simplify. 10x minus x is 9x. We're going to bring back down the minus 3. Now here's the tricky part. What is 1x minus 1x? What's 3 minus 3?
0.
What's 5 minus 5? Yeah, anything minus itself is 0, right? So that is the tricky part for some reason. When there's just 1x there, that throws everybody off kilter. It's just 0. So now we don't have any of our if necessary things to look at. We don't have any fractions. We no longer have variables on both sides. We don't have any parentheses to multiply. So now all we do is undo our operations. So if we read this out loud or to ourselves with the operations included, 9 times x minus 3 equals 0. Now I know I need to undo the minus and I need to undo the multiplication. Always going to start with the undoing the minus. Plus 3 is right.
On both sides.
On both sides is right. We only do things with both sides of an equation. We cannot do it to one side. Okay, so now we've got equals 3 over here. Negative 3 plus 5 and a 3. That simplifies to 0. Which we wanted, we're trying to get our x by itself. So we've already undid the subtraction by adding. Now we're going to undo the multiplying by what?
Dividing.
By dividing. We're always starting on the side of the variable. So we're dividing by 9.
3. X equals 6.
X is not equal 3. Be careful.
Wait, what?
X equals 3/9. And now we're going to simplify that. If you've forgotten how to simplify, I want you to do it on your calculator right now. 3, ABC 9. And you will see what that simplifies to. A lot of you can simplify 3/9, but it's still valuable for you to know how to use it. Yes, 1/3. It's valuable for you to know how to simplify on the calculator, because sometimes they're big numbers that we don't know the factors to, right? So it's quite convenient to have a tool that will simplify them for us. So now we know x equals 1/3. So you can box, circle. Some of you like to highlight. I would also be okay with you highlighting. I don't want to do number 3 yet. We are going to do number 3.
What about, we have some even,
Sorry?
we have some uneven that, with that math.
Yeah, so we are going to do one like that. I want you to do one. I guess there's not one where you have to just distribute something without it being a fraction. So I guess I'm doing a little bit of that one. Okay. So we have some if necessary in our notes. If necessary, distribute, then combining like terms. If necessary, get rid of the fraction by multiplying by the least common multiple of the denominator. But in this case, we've got a fraction and, parentheses. We have a couple options. We could go ahead and distribute, and then get rid of the fraction. I propose that we don't do that. I propose that we go ahead and get rid of the fraction first. What we're going to do is multiply everything by the least common multiple of our denominators. If you only have one fraction, that is the least common multiple. That's the only fraction, so we know we're going to multiply by 7. So 7 over 1. We're going to multiply that by our fraction. We do not multiply it by what's inside the parentheses because eventually that's going to be distributed later. And now we're going to multiply by the other side. So 7 times 3, that's 21. 1 times 7 is 7. What is 21 divided by 7 simplified to? 3. And you also could see that they will cross cancel here because we're multiplying, right? Top times top over bottom times bottom. So we're going to have 3 times 14x minus 35 equals 7 times 5, which is 35. So now we're going to distribute the 3 to everything in the parentheses. And that makes this 42x minus 115, 105. This 3 times 35. 105. So now, we don't have variables on the same side, we don't have any parentheses left to give anything into, we do not have any fractions. Now we are just solving. So our operations we're undoing, again, are subtraction and multiplication. 42 times x minus 105 equals 35. So we're going to undo subtracting by what?
Divided.
Nope. Adding. What are we going to add, Kim?
105.
Yep, we're going to add 105 to both sides. That's right. So now we're going to have 42 times x equals 140.
So divided by.
Yes,
42.
42 times x. We're going to divide to get rid of it. So we're going to divide by 42. Use your calculator. You don't have to worry about simplifying this. Just go ahead and put in 140, ABC, 42, and tell me what you get.
3
and 1/3. If you want to leave it as a mixed, as an improper fraction, which typically we do, I'm going to hit the second button and then that arrow button. What do you get? Oh, I lied. Hit the second button and the arrow button again. Just take it back. 140, ABC, 42. Now it's second button and ABC, I think. There you go. What do you get? 10 thirds. That's preferable, but 3 1/3 is also acceptable. Any questions? All right, right now we're not going to do number 5 because that one is just like number 3. So for right now, I'm going to scratch it. Don't scratch it all the way out yet. We might come back to it. Anybody that sees an odd one that they want me to do that looks like, maybe looks like an even one that you don't know how to do or you're not comfortable with doing. 7 and 8 both look like the one we just did. Let's look at the back page. Jacob?
There's no odd one that has two different denominators in it.
There's not? Yeah. Sure, we'll do one of those. How's that? How many of those do we have that are even?
Only one of them.
Only one?
No, there's two. And then that's one.
Sorry, I'm looking at, okay, so there's 14 and 21. 14 and 21. And 8 also. Oh, and 12. All right, well, we'll go ahead and do number 12. Let me see how it looks. Compared to 18. Well, I don't know, 14 and 21 look a little bit more more challenging, what do you think? Would it be 14, 21, or 12? Okay. So, a denominator of 3, a denominator of 5, we do have variables in the same size, but I actually don't want to even add, if I take this and start trying to combine my terms, now I've got to add and subtract fractions. So the very first thing I want to do here is get rid of my fractions. So I'm going to multiply everything by the least common multiple of 3 and 5. So 3, 6, 9, 12, 15. I know that 5 is also a multiple of 15. 5, 10, 15. So 3, 6, 9, 12, 15, and 5, 10, 15. You'll see that 15 is the least common multiple. I'm going to multiply everything by 15. Now that's 15 over 1 because I'm multiplying fractions. So now, there are no parentheses here, so I'm literally just shooting the 15 to everything in here. On number 14 and number 21, if you choose to get rid of the fraction first, you're only going to be multiplying your multiple by the outside of the parentheses here. Okay, so 15 times 1 over 3. I'm going to not take any shortcuts just so that you see it. 15 times 7, is that 105 again? Minus 15x equals, is that 90? 15 times 6 is 90 plus 30 over 5x. So right now you're thinking, listen, you did not get rid of any fractions. But, remember, we just didn't simplify them here. That is 5. This is 6. So really what we have is 5 times x plus 105 minus 15x equals 90 plus 6x. So now we're going to combine things on our left side. Because I've got two variable terms on my left side, before I start getting them together from both sides, I got to combine these first. So 5x minus 15x is negative 10x. And I'm going to bring down my 105, my constant, and now I'm bringing down my right side that I didn't do anything with. Any questions about how we got there? You with me, Zanaya? You with me, Caleb? Make sense, Jacob? All right, now variables on both sides. We add the opposite of the smallest variable term. Now remember, negatives are always smaller than positives. This is a negative 10x, and this is a 1x. So which one is smaller, negative 10x or positive 1x? Which one's smaller, negative 10 or positive 1? Negatives are always smaller than positives. So we're going to add a positive 10x, a positive 10x. You add opposites, they're 0. This is 0 plus 105. And 90 plus 1x plus 10x. So I'm going to put 11x plus 90. That order doesn't matter. Now I've got 105 equals 11 times x plus 90. I'm undoing multiplication and I'm undoing addition, but I'm going to undo the addition first. How am I going to undo adding 90, Kimani? Subtract what? Yep, 90. You're always subtracting whatever you're adding, you're always adding whatever it was being subtracted. That exact same thing. We want the opposites there. Opposites are the exact same digits, but different signs. And when you add together, they equal 0, and that's what we're going here for here. 105 minus 90 is 15 equals 11 times x. How am I going to undo multiplying by 11? Dividing by 11, that's right. equals 15/11. So if you put that in on your calculator, 15 ABC 11, and hit equals, you'll see you have 15/11 because that is in simplest form. Does that help, Jacob? All right. Any other problems you want to do something that looks like it? I want to do odd ones. We could do that one even, so now you're down to only 11 problems that you have to do by yourself. So we're looking at even ones again. How about number, not even ones, but odd ones again? Yes, let's do 19. So, we have some if necessaries, right? One of our if necessaries is if there are variables on both sides, we need to get them on the same side. But here's the thing. There are variables on both sides of this equation, but if we need to distribute, we need to do that first. Before we start getting variables on the same side, we always do all the other stuff first. So we're going to distribute and then combine like terms before we start getting variables on the same side. So we didn't do anything to this x, we just bring it down, and that's plus 2x. And that's 2 times negative 1, so that's minus 2. Are you with me, Gil? And we're not doing anything to the right side, so we just bring it down. Now we've got to get everything we can combine on one side together. So x plus 2x minus 2. What can I combine on the left side? Aiden, are you following along with me, buddy?
What?
Are you following along with me? Just not looking at the board. Sit up. Thank you. What can I combine here? If I have x plus 2x minus 2, what can be combined? X and 2x, that's right. What is x plus 2x, Caleb? Well, that's a 1, right? Yes. To add like terms, you add their coefficients. To subtract like terms, you subtract their coefficients. So that's 3x, we're going to bring down our minus 2, equals 2x minus 3. All right, now what do we do? Sydney, you do not appear to be following along with us. Where's your pencil? What do you think we should do now? What do we do to get the variables on the same side? Any idea, Kim? Look at our notes. We wrote something down on our notes. What do we do? What do we add? No?
Oh, you know.
Look at your notes. What does it say to do if you need to get the variables on the same side? Find it? What's it say to do? Renee, did you find it? What does it say to do if you need to get the variables on the same side?
Adding the opposite of the smallest variable.
Yes, we're going to add the opposite, the smallest variable terms on both sides.
So our smallest variable is 2, right?
It's 2x, right? So this is a variable term, and this is a variable term. 2 is smaller than 3, so we're going to have the opposite of 2, so we're going to subtract 2x from both sides. When we do, we're not dividing now, we're just marking that as a like, variables on both sides. 3x's minus 2x's gives me 1x minus 2 equals, notice went to 0, that was the whole point of that, equals 3. So now we have x minus 2 equals negative 3. We only have one operation to undo, and that's subtraction. How do we undo subtracting, Tyrese? How do we undo subtracting? I'm subtracting 2. What do? Feeling what happens? Add. What is it add? Yep, let's do. Adding a 2. Subtracting 2, so we're going to add 2 to both sides. And x equals, when that goes to 0, on your calculator, 3 negative buttons you like me to use number 21? Number 21 looks a lot like number 20. Yeah? Okay. So number 20 has fractions, two with different denominators. This is a little bit more complicated than number 20, but it's going to basically do it the same way. The first thing we're going to do is I want to get rid of my fractions before I start doing anything else. So what is the least common multiple between these fractions? Well, first off, let's do this. Let's move that negative to the numerator here. Okay? So now I'm looking at a positive 2 denominator and a positive 3 denominator. What is the least common multiple of 2 and 3? Very good, it is. If you start counting by 2s and you start counting by 3s, the first number that you get to that's the same is 6. 2, 4, 6, 8, 3, and 6. 6 is that least common multiple. So we're going to multiply everything by 6 over 1. So now, this fraction is on the outside of parentheses. So we only multiply the fraction, we do not multiply this part. So that's going to be negative 6 over positive 2. That equals negative 3, right? So I'm not going to write that there. I'm going to write my negative 3 here. Does everybody understand what I did? I'm going to bring down what's in the parentheses because I haven't done anything to that yet. Now, over here, everything is, nothing is in parentheses, so both of those have to get multiplied. So 6 times 2x is 12x, minus 6 times 2, which would be 12, and 1 times 3 on the bottom, and that's going to simplify to 4. So now, I've gotten rid of my fractions. Now I'm going to distribute, and then look for my next if necessary. This is negative 3x plus 3 equals 12 times x minus 4. So which if necessary do I have to deal with now? Look at your if necessary things in our notes. What's necessary to do before we start undoing our operation? We already distributed. That was a good one. So good job. What's the next thing we're going to do? What's the next if necessary now? We already got rid of our parentheses. Perfect. Perfect. So I've got a negative 3x here, that's a variable term, positive 12x here. Which one's smaller, negative 3x or positive 12x?
Negative 3.
Good. And what's the opposite of negative 3? Positive 3, that's right. So we're going to add 3x here and add 3x here. So that goes to 0. 0 plus 3 is 3. 15x. Bring down our constant over here, minus 4.
So you get minus 15 in both ends?
No.
Wait, no, yeah.
So if you read this out loud, it'll tell you what's happening, so we'll know what to do. 3 equals 15 times x minus 4. So I need to undo the times, and I need to undo this minus. I'm going to start with the minus, right?
Can you flip it enough? Do we do it?
We could flip it. You want to write it as 15x minus 4 equals 3. You could do that. But it doesn't change what we're going to do, right? Which one are we going to undo first? The subtraction or the multiplication?
Subtraction.
Right. How do we undo subtracting? Adding. 4 is being subtracted. We add 4 to undo that. And we're going to do it to this side.
Now we divide.
Now we divide. What do we divide by?
15.
15 is right. And so x equals 7, 15. You want to start out your geometry year strong next year, you should be working on solving equations over the summer. If you're not comfortable solving equations, that's what you should be working on over the summer. Because we are going to do things that are completely different than algebra, but unfortunately for those of you who do not like to solve equations, be a lot of equation solving in geometry. Any other, ones you guys wanna go over, any other odd ones we do? I feel like we may have done one of kind of all of them. 18's a little bit different, but, I'll just tell you, I would just distribute first, and then you can get rid of your fraction. You could get rid of your fraction first, and have it to you, but you may wait, probably just as you distribute first. Anybody see an odd problem that you wanna do because it looks like one of the easy ones? Alright, well, I'm gonna let you guys work, let's cross out the ones we're not gonna do that are odd, because remember you're responsible for everything we didn't do together. So, that we did together, we're not doing 13 or 15 or 17. We did 19, so you should have that done. We did 21, so you should have that one done. This is part of 21, not 24. 24 you've got to do. We didn't do 23.
So we're not doing it.
We're not doing 13, 15, 17. We did 19 and 21, so those should be done. Don't cross those out. We did 1, we did 3, we're not doing 5, we're not doing 7, we're not doing 9 or 11. But you are responsible for having all the problems that we did together on there. So there are odd problems we did together, those should be on your worksheet. You do not get credit for this assignment. Leave it as a fraction. So again, just ask the question, do we round, you're just gonna leave your, as a simplified fraction. So if you're not sure if it's simplified, put it in your calculator. 205, ABC, whatever your denominator is, just to see if that's simplified, okay?